welcome to section 8.2. This is actually a pretty big lesson. It's something that is a skill that will come up again and again and again. And so this is not a one and done situation. This is something more like factoring, where you're going to find elimination and substitution both throughout your math studies. So I would encourage you to make sure that you master this and not just learn it to get through the test kind of situation. So there's two types of solving systems in addition to graphing. There's a few other types as well. You can use some technology. You can do some things with something called matrices. But these are two of the most common ones. And the first one we're going to learn is substitution. So to not babble any more than I already have, here's the idea. We're going to take one expression and substitute it in the other equation. But you have to have one variable already solved. So this first one works because I gave it to you in x equals form. And so we're going to take away this x here, and we're going to plop in this value. So it's going to look like this: y plus 2 plus y equals 4. Instead of this original x, we're going to have this y plus 2. This piece right here used to be the x. And then we're just going to continue to solve. So now we have only one variable. 1y plus 1y is 2y plus 2 equals 4. Take that 2 to the other side. We're going to have 2y equaling 4, take away 2 is 2. Divide both sides of my equation by 2, and y equals 1. Now, it's not quite enough to solve for one variable. You need to make sure that you solve for both. And so oftentimes a big thing I hear from students is, I don't know where to go back and plug it in. We've got to plug it in so that we can figure out what the x value is. This is the perfect place right here because it's already solved for x. So instead of y plus 2, we're going to substitute this value. So x equals 1 plus 2. 1 plus 2 is obviously 3. And so then we typically write our answer just like we did with graphing. We write our answer as an ordered pair. So it would be 3, 1. And we're just going to repeat that process with a couple of different types of examples, but that's the gist of it. So look at example 2. It does look like it's more difficult. Don't despair. What you need to make sure you do is just find a variable that you can isolate. Find a variable that you can get all by itself. So look at this y right here. That y right there doesn't have a coefficient. So all I would have to do is move this 2x to the other side, and that y would be all by itself without any fractions or anything involved. And so I am going to take this equation right here. I'm just going to write it underneath. I'm going to take that 2x to the other side. So you have to manipulate the equation so that you have something that can be substituted. So now right here, y is by itself, negative 2x plus 6. And now I'm going to go to this second equation, and I'm going to plug that negative 2x plus 6 right in here for that y. So I'm going to start off with the 3x. I'm reading straight off this equation, 3x plus 4. But instead of writing that y, I'm going to write this negative 2x plus 6 piece. Don't know why I chose to do this in red. And then multiply through, and we're going to solve it for x. So now we're down to one singular variable. Multiply this through, just like we learned in chapter 3. So negative 8x plus 24 equals 4. 3 3x minus 8x is negative 5x plus 24 equals 4. If you are good at this skill, feel free to start skipping some steps. I would do some of these kind of in my head, but I don't want to confuse anybody. And so then this is negative 24, take away 24, and then divide by minus 5, divide by minus 5. I'm running out of space here, so I will do that part just verbally. Two negatives are going to make a positive, so x is positive 4. All right, let's get off that red. Where do I substitute that x back in so that I can find a y value? You could do these original equations if you wanted, but you don't have to go that way because you could use where you already have it solved. You could plug a 4 in literally right there, and that's going to automatically give you what y is without any manipulation required. So y equals negative 2 times positive 4 plus 6. Negative 2 times 4 is negative 8 plus 6. Y is negative 2. And then just write your answer as an ordered pair, 4 comma negative 2. Remember the x goes first. Here's a third one. If you're ready, feel free to pause and try always at any time. I am going to solve it for b, and I need to be mindful of that negative. So the very first thing I'm going to do is subtract 3a, subtract 3a, draw my line. I get negative b equals minus 3a plus 6. There is a negative 1 in front of this, so imagine dividing all three things by negative 1. It's going to have the effect of changing all of the signs. So it would change that to a positive, that to a positive, and that to a negative 6. All right. So now I've solved the second equation for b. b equals 3a minus 6. So now that's what I'm going to plug into the top equation for b. So 2a plus 6, 3a minus 6 equals 4. It's all in one variable. The first step, I need to get rid of those parentheses by distributing that 6. So 2a plus 18a minus 36 is 4. Add my like terms. In the last problem, I referred to starting to jump some steps. What does that look like? Well, instead of writing plus 36, you know when you jump that over, it's going to become a positive. So you can just kind of mentally go 4 plus 36. So this next step is going to be 20a equals 40. Do it out the long way. And then, if that didn't make sense, and then divide, oops, for some reason I'm frozen. Divide by 20. Divide by 20, so a equals 2. Think about where you're going to plug that 2 in. Where is the most logical place? I would choose right here. And if that's too messy for you, take a second and just rewrite it so you can see how neat it is. And plug that 2 in for b, or for a, to solve for b. 3 times 2 is 6. 6 take away 6 is 0. And then usually it's x, y. Let's put it in alphabetical order for a and b. So 2, comma, 0. All right, there are special cases that are going to come up. This one enables me to kind of show you two different special cases at the same time. This example sometimes confuses students because you see y equals for both of them. So it's like, gosh, they're already solved. What do I do? You literally just take these two and set them equal to each other. Imagine taking this y and substituting this in up above. So the y's just kind of drop out, if you will. So minus 3x minus 2 equals minus 3x plus 5. Numbers are going to go towards the right, typically. So negative 3x equals negative 3x plus 7. Jump the 3 x's over by doing the opposites. And then something very disturbing is going to happen because now your x's drop out. And oh, I remember being freaked out when that would happen, being like, did I make a mistake someplace? What has happened? Okay. So what happens when your x's drop out completely? Well, you end up with a situation. You have to ask yourself if this is a true statement or a false statement. So let me do it a different way, because some of you are probably like, how would I know if it's true or false? So let me take this back just a second, and you'll see a little bit easier. If I take it back to here, and this should be helpful if this happens to you too. If I take it back to here and I do this piece first, and those x's drop out, I end up with negative 2 equaling 5, because a negative 3x and a positive 3x is no x's, right? So you always have to have an x, because that's what you're solving for. So you know that's going to be when it's a special case. Is this true? Because here we have this weird statement that says negative 2 is equal to 5. That is not true. When it is a not true statement and your x's drop out, what you write is empty set. It's called empty set. It is not a 0. It is a line with a slash through it, like a no speeding zone or something like that. Think of like a traffic sign. So it has to have that slash. The other special case is literally the opposite of this. So let's solve this for one of the variables. Let's solve this. This is going to be a little bit more complicated. Oh, this one is better set up for elimination. Let me circle back to this one. And I will show you what happens with this one in a little bit. So now we're going to look at elimination, just because it's going to involve fractions and we're going to not get a very nice answer. So I would ignore that one for the moment. And it's all set up for elimination. Okay, elimination. I have typed out the steps for you. It's not as hard as it looks. Just if you look at the number of steps and how many words, don't get intimidated. So line up your equations in the same order. Look down here. So I see how I have my x's, and then my y's, and then my equals, and then my constants. So that's all that means. Manipulate as needed. So this is key, because every problem's going to have a little different vibe to it. So that for one variable only, the coefficients are opposites. So in this first example, I've got a negative 3 and a positive 3. So I obviously started our examples with an easier type of problem to show you. And so there's nothing to manipulate. I lined it up for us. I already manipulated it. All right. Step 3 says add columns and eliminate a variable. Hence why they call it elimination. So what we're going to do is we're going to draw a line, and we're going to add the columns straight down. 2x, take away 4x is negative 2x. Negative 3y plus 3y is nothing. That drops out completely. 0 take away 1 is -1. One of my variables went away. Solve. Because now we can solve it because we only have one letter showing. So divide by -2, divide by -2, and x equals a negative over a negative is a +1/2. Now, it's gross that it's a fraction. I don't give you a bunch of fractional answers. And so I want to show you one because you know it's going to show up occasionally on homework and future things. So you don't want to necessarily destroy your original equations because you're going to have to substitute back. So I was able to do that because I am able to erase really craftily, if that's a word. All right, so where am I going to put that x? Which equation looks easier to you? This one has a 0. So I would go in the place that it's easier, but pick one of these. I would probably pick the top one. So I am going to substitute 1/2 for that x. Minus 3y equals 0. 2 times a half, think of if you have 2 half cookies, you have a whole cookie, or use technology. 2 times a half is 1. Take the 1 away, take the 1 away. Divide by -3, divide by -3. And y equals +1/3. And then you know that we're going to write our answer as an ordered pair. So don't freak out that we got fractions. I feel like this is the same. Grant me just a little patience here. 2x minus 3y is 0. What did I have on this one as a special case? I feel like I typed this wrong, which is why when I glanced at it, I was like, I think I typed the same thing twice, and this is not. So I'll make sure I cover a special case with the elimination. My apologies. Considering I'm 17 minutes into the lesson, and I didn't catch that clearly till just now, I'll make sure you see the other special case. So thank you for your patience. All right, number 2. Let's go revisit our steps again. Line up your equations in the same order. Are we good on that? X's, Y's, yes. Manipulate as needed. Okay, so I think on this one, we're going to practice that skill. Manipulate as needed. I need to somehow create a situation where I have opposites in front of the same letter. So, for instance, right now this is a 1, and this is a +2. If somehow I could make this -2x, that would just be fabulous, because then these would be opposites, and when I added them straight down, it would go away. So, could there possibly be some way that I could do that? As a matter of fact, there is. You're allowed to multiply equations by any number or divide them by any number, as long as you do it to everybody. So we're going to take that entire equation and multiply it through by a -2. So this guy right here stays the same. 2x minus 5y equals -17. And this guy changes. -2x minus 6y equals, big place of mistakes for students. Don't forget to multiply it through by everybody. -16. And then we're going to add my columns straight down. So one little trick, and now we're ready to add the columns. 2x, take away 2x. This completely goes away. 0 x's. A -5 and a -6 make -11y. -17, -16 make -33. Divide by -11. Let's finish it up. Divide by -11. Y equals 3. find somewhere that looks the easiest to plug in that y. In this case, I would probably pick this one right here. This is another hard spot for students to finish elimination. Not a complaint. A concern is that I don't know where to put, where to plug it back in to find the other variable. So if that's happening to you, you're not by yourself. You're not the first person that has struggled with that. Go back to the original equations and find the easiest looking one. So we're going to plug in that 3 right there. So we're going to go x plus 3 parentheses 3 equals 8. So x plus 9 equals 8. Subtract the 9. And x equals -1. Write it as an ordered pair. And we're good. Let's make it a little trickier. Look at question 3. Think about how that's different than question 1 and question 2. And the answer should be, it's not all pretty and lined up. My equals are all out of whack. I've got y on the left here. I've got y on the right there. We need to make it pretty. So we need to jump that -4 over the equal sign. Now here's a little trick. And if it's negative on the right, it's going to be positive on the left because you're going to go plus 4y plus 4y. So this one is going to become 5x plus 4y equals 22. And this one doesn't need any manipulating at all. All right. Now, the problem is that none of these are opposites. So I'm kind of needing to think through what I can do. Well, I can do a couple of different things. One of the things you can do is think through what kind of that common denominator would be. I need a number that 5 divides into and 3 divides into, or 4 and 8. And since 4 and 8 actually have more commonalities, I'm going to use the y's in this example because 4 goes into 8 2 times. So if I just somehow made this a -8, that would kind of solve my problem for me. Not kind of, it would solve my problem for me. I would be able to add those and that would go away. So how do I make a +4 into a -8? I'm going to multiply everybody through here by a -2. And you can rewrite that all right here, or I'm just going to write it down below right here. So -2 times 5 is -10x. -2 times 4 is -8y. -2 times 22 is -44. And then I'm going to be ready to add my columns. Now, you don't need this anymore, so if this confuses you, you can scribble it out. That's totally fine. I've got what I need. I have a +8y and a -8y. Add my columns. -3 and -10 is -13x. Y's drop out equals a +18 and a -44 is a sorry, for some reason I'm blanking on that. I don't know why. 44 minus 18. I want to say 26, but I was losing my confidence there. Divide by -13. Divide by -13. X equals +2. Let's go back and plug it in. I'm not going to use any of these equations to plug it in. I'm going to go back somewhere original. This one has bigger numbers, but I'm going to have less manipulating with this one. You get to pick. If you don't like what I chose, do the other one. -3, x is 2, plus 8y equals 18. -6 plus 8y equals 18. Add the 6. 8y is going to be 24. Divide by 8. Divide by 8. And y equals 3. Okay. Hope you're getting it so far. We have one more before we kind of get into special cases and things like that. And so now there's just no apparent common denominator. There's no coefficient here on question 4 that's a 1. There's just nothing easy. So what do you do in this case? Usually I just tell my students, because sometimes it's easier to actually find the common denominator. But more often than not, you can just do a little trick like this. Take this number and put it down here. Take this number and put it up here. And we're going to multiply the top equation through by 3, the bottom equation through by 4, and then notice that I'll need to change that to a negative, so it'll be a negative 12. So this is going to create, I'll erase this in just a second, this is going to create a positive 12x here and a negative 12x here, and then I'll be able to eliminate. So that's my strategy. It's going to take a little bit of paper to get this done, but that's the idea. And I don't think red is super helpful, so I'll do a positive 3 here and a negative 4 here. All right, so where am I going to write that? I'm just going to use all this space. So 12x plus 9y equals 33. Don't forget to do everybody. And then negative 12x minus 8y is negative 28. So multiply that through, and then you're all set to eliminate. So bye-bye x's. 9y minus 8y. Look at that. You don't even need to divide here because that's just y. 33 minus 28 is 5. So we're done. One step and done. All right, where are we going to put the 5? We want to use one of these original equations. I like this one. So 3x plus 2 times 5 is 7. So 3x plus 10 is 7. Take the 10 to the other side. So 3x is minus 3. X equals negative 1. Done. Oh, divide by 3. I just kind of did it. Sorry. Divide by 3, divide by 3. I was thinking about my mistake, and I was concerned. On this case right here, next page, I have special cases, and I was already thinking about, I hope this works out to be the one case that I didn't do, because my hard copy of all these notes is across my classroom from me. All right, let's look at this special case. We have a problem because we need to line everybody up, and so I need to manipulate I'm just going to switch the order there. I don't have to jump anybody over the equals. I just am switching the order. Here, though, I've got to get that 8x over the equal sign. So this one's going to become a positive 8x minus 12y. And then this is plus 24, so I've got to jump it over. Let me slow down. I don't want to lose anybody. That's not my goal here. So negative 12y plus 24 equals minus 8x. Add the 8x over. You get 8x minus 12y plus that 24 is still there. I didn't leave anybody on the right. No big deal. Now jump that 24 over the equal sign. So it's going to be 8x minus 12y is negative 24. And that's what I'm going to write right here. All right. So if you need this, you can always circle back and pause the video. All right, so now let's look here. All right, what will I do? What will I do? I will probably take that top equation and multiply through by 4. Why 4? Well, because 4 times -2 will give me -8, and -8 and +8 make 0, and so then that will drop out. So this piece right here will become -8x plus 12y equals 4 times 6 is 24. If we rewrite the bottom, we get 8x minus 12y equals -24. Fabulous. Exactly what I wanted to happen will happen as I add these columns. -8x plus 8x, that goes away. 0 x's. 0 y's here. Positive or negative, doesn't really even matter. And 24, take away 24 is 0 there. So I end up with 0 equals 0, which it isn't so important that it's 0. It's important that it's true. And so then when you have a true statement, in other situations, you might end up with like a 2 equals 2 or something like that. As long as it's true, then your answer, your solution, is written in interval notation, is -infinity to infinity, or all real numbers. So all the numbers are true. Literally, you could plug in anything and it would work. All real numbers, and so the set of real numbers can be abbreviated like that. All right, our last example has to do with clearing fractions and decimals. If you notice a glitch in our video, I've got to pause real quick, and I'll do this one in just a second. All right, for our last problem, you are going to come into contact with word problems using this stuff. It's one of the lessons that you will see, I think, next, as a matter of fact. And so occasionally you're going to see fractions and decimals. Do not get intimidated. We're just going to get rid of them. So if you have a problem that has a decimal, you're going to multiply through by a power of 10 that clears the decimal. Now, that's not going to connect with everybody, so let me explain. And I can kind of babble here because I can erase it really quickly. If you have something like 0.6 and I multiply it by 10, that gives you just, it clears the decimal. It gives you the number 6. If you multiply it by, if you have a decimal like 0.04, since you have a 2-digit decimal, you need to multiply through by 10 squared, or something that has 2 zeros, so that it clears the decimal. If you had 0.0008, you would need to multiply by something with 4 zeros in order to get that decimal out of there. I hope that makes more sense. Okay, so let's get rid of all this. In this problem, it's just a 1-digit decimal. So we're just going to multiply everybody through by 10. So that's going to give you 2x plus 3y equals 17. Use the technology as needed. Over here, excuse me, over here, we've already practiced some of this with clearing fractions. We need to multiply through by the common denominator. So, hold on, I gotta get water. All right, as I'm choking, not an Oscar-winning moment for sure. Okay, if you want to rewrite this so that it's more clear that the denominators are what they are, you can rewrite it like this. And then I am quite certain that in chapter 3 we talked about how to clear fractions. So between 7 and 5 and 35, my common denominator is 35. So you're just going to multiply everybody through by 35. So if I multiply this through by 35, 7 goes into 35 5 times. 5 times 1 is just 5x. If I multiply this by 35 and the denominator is 5, 5 goes into 35 7 times. 7 times 1 is 7y. And here, if I multiply by 35 and divide by 35, that just goes away, and you get that. And so by clearing that out, if you look at these two, now all of a sudden it's a little bit more manageable. And why it's not like necessarily like you're not ready to eliminate yet, you certainly just need to multiply the equations and you'll be good to go without a big problem. So perfect opportunity to kind of pause the video and practice that. I will probably, let me write this underneath here. I will probably multiply this top equation here through by 5 and the bottom equation here through by -2. So that we end up with a plus 10 here and a minus 10 here. So we're going to get 10x plus 15y equals 5 times 17 is 85. Down here, we're going to get -2 times 5 is minus 10x minus 14y equals 2 times 29 is -58. And now I'm ready to eliminate. So 10 take away 10, that just blah, 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 goodbye. 15 minus 14, y just is 1y, so that's great. And then 85 minus 58, I feel like that's 27, but let me double check. Oh, look at me, 27. Plug it back in, find the easiest looking place, the smallest looking numbers. I'm going to choose the top one here. So 2x plus 3 times 27 is 17. So 2x plus 81 is 17. Take that 81 to the other side. 17 take away 81 is 64. Divide by 2. Divide by 2. And we get 32, comma 27. So x is 32. All right. That's it. It definitely requires practice, but as you can see, I'm kind of going through the same steps every single time. So it is a little bit more, you know, if you have a good handle and grasp on your multiplication tables and have a, you see number patterns and things like that, that's definitely going to make this lesson a little bit easier sometimes because you know those multiplications without having to type it all in. But the ideas are the same whether you use your calculator or not. So good luck. Go ahead and practice. And I say it every time, but not everybody maybe hears me or feels comfortable doing it. Please text me. And I will, if you just send me a picture of the problem that you have, I will work it out either on paper or I'll make a little video talking about my steps so you can hear me, and then I'll just send it right back to you on your phone. So that will get you the quickest help possible, and as long as you're not texting me at 11 o'clock at night, that's great. I'm happy to do that. And so the course definitely does get more difficult as we go, so feel free to use that option as needed. Take care, everyone. Bye-bye.